Okay, when we're adding and subtracting, the biggest thing you can remember is that we need to have a common denominator. In order to get a common denominator, we need to factor the denominators of all my terms. So in this case, only the first one is going to factor, and that would be y minus 5, y plus 4. So when I look at my two expressions here, I notice that they both have a y plus 4, but my one on the left has a y minus 5, and this second one does not. So I need to multiply by y minus 5 over y minus 5. And I'm going to leave my denominator factored. So that would be y minus 5 times y plus 4. My first fraction is just y in the numerator, and then I would have 2 times y, which would be 2y, 2 times negative 5, which would be negative 10. And then I simplify. So that would give me 3y minus 10 over y minus 5, y plus 4, and that's my final answer. Technically, I should say y can't be 5 or negative 4. And that's all we have to do. So looking at problem 2, I have to factor both of these denominators. 3 over x plus 5, x minus 2, plus 1 over, careful here, x plus 5, x plus 1. So let's compare our neighbors. X plus 5, we're good. X minus 2, my right one does not have x minus 2, so I need to multiply by that at least. And then x plus 1, well my first one doesn't have an x plus 1, so I need to multiply by x plus 1 over x plus 1. So I have this lovely long denominator of x plus 5, x minus 2, x plus 1, and then I can simplify my numerators. 3 times x would be 3x, 3 times 1 would be 3, plus 1 times x would be x, negative 2 times 1 would be negative 2, and if I combine like terms in the top, that would give me 4x plus 1 over x plus 5, x minus 2, x plus 1. Sorry, I kind of ran out of room there. X cannot equal negative 5, 2, or negative 1. Okay? The last two were more complicated because once I combined my numerators, I could still factor. So for the most part, we got that we needed to factor the denominator, so that would be x minus 4, or sorry, n in this problem, n plus 4. Mostly we saw that I already have an n plus 4 in both, but my first one does not have an n minus 4. So most of us saw we needed to multiply by n minus 4 times n minus 4. And once again, as pleased, most of us saw we need to distribute, so negative 2n plus 8 minus n squared. And I'm just going to play with my numerator for a little bit and not write the denominator. And a lot of us rewrote that in standard form. And this is where we got a little crazy with our factoring. Now, we didn't really factor things where I had a negative leading coefficient. And y'all tried to find different ways to get around this. The easiest way is to pull out a negative and change all the signs of your three terms. So it'd be a positive n squared, a positive 2n, and a negative 8. And then we can factor that. I'm going to plop him over the denominator again. So what multiplies to negative 8 and adds to positive 2. And I need to leave that negative in the front. So that would be n plus 4 times n minus 2 all over n plus 4 n minus 4. And then my n plus 4's cancel, so my final answer is negative n minus 2 over n minus 4. So I was really impressed if you got that one right. Once again, in the last problem, I need to factor my denominators. So x plus 2, x plus 3, minus 2 over x plus 2, x plus 1. We already have an x plus 2 in both of them. Left one has an x plus 3, right one doesn't, so I need to multiply by x plus 3 over x plus 3, which is just 1. And my right one has an x plus 1, but the left one doesn't, so I need to multiply by x plus 1 over x plus 1. So I get this really ugly denominator, x plus 2, x plus 3, x plus 1. And my numerator simplify to x times x is x squared. X times 1 is x. Then we need to be careful because I have a minus, so we're going to have to distribute that negative. 2 times x is 2x. 2 times 3 is 6. So that's going to change some of my signs. So that would be x squared plus x minus 2x minus 6. Once again, I'm just going to skip writing my denominator for this step. So that would be x squared minus x minus 6, which, hey, will factor, and I'll get x minus 3 x minus 3 x plus 2 over my denominator, which has an x plus 2, so those are going to cancel. Okay, kind of ran out of room, sorry. X plus 2, x plus 2. So my final answer is x minus 3 over x plus 3 times x plus 1. So those are tricky because you needed to see that this was still able to be factored. Now, if it was like x squared minus 6, something that doesn't factor, then obviously I wouldn't worry about trying to factor the top. But you always want to double check and make sure that you've simplified all the way down.